So these are the topic tests available on the Bodhee Prep Android app. More than 200 such tests are available. The app for the link is in the description below. Make sure you download the app and make use of these tests. So what are these tests for? Once you have gone through the basic concepts of a topic, and you want to gauge your level of performance in that topic when you do write a test for that topic. So the idea for these tests is to help you gauge your performance. Once you've gone through the test, it would be a good idea to look at this video after your attempt. So in this video, we try to give you a perspective of what could have been a good attempt in the test. We'll solve the test live and see what would have been a good attempt, the amount of time that should have been put in the test, and the kind of question that could have been chosen. So that is this video. This specific video talks about the test on simple interest, compound interest. Test number 4 is mentioned in the app. To give you a brief analysis, this test was about a moderate level of difficulty, and anything which is around 5 to 6 questions net correct would have been a good attempt. So when I say good attempt, that means you could expect a 95 odd percentile in the section. Also, in terms of attempt time for this test, my attempt time will be higher, about 24 to 27 minutes, because there were a lot of questions which involved calculations. So, since we are trying to find answers and not use the calculator as much as possible, therefore the attempt time would be a little higher for this test. But net we're looking at about 6 questions. To start off with the questions, for example, question number 1. Now, if you look at question number 1, it says, Amar purchased a piece of land for 5 lakh rupees. It appreciated R% every year. A land will appreciate like compound interest for 3 years. Had he invested this in a scheme with R% simple interest, the value of the investment would have been 6,64,000 less. Find the value of R. Now, clearly, we have to find out the difference between SI and CI for 3 years. This is given as 3PR squared upon 100 squared plus PR cube upon 100 cube, a direct formula that we can use. As long as the value of R is given, the calculation is not very difficult. But if P or the difference is given, the calculation can become a little taxing. The difference for the 3 years is SI is 64,000 less than CI for 3 years. So 64,000 is equal to 3 into 5 lakh, 5 lakh P square upon 100 square plus, sorry, R square plus 5 lakh 1, 2, 3, 4, 5 into R cube upon 100 cube. So what I'm also doing is simultaneously I'm expanding 100 square and 100 cube to accommodate for the zero. So 100 square is 100 into 100. 100 cube is 100 into 100 into 100. Double zero cancelled. Double zero cancelled. This becomes 1 by 2. Double zero cancelled. Double zero cancelled. So we get 64,000 is equal to 150 R squared plus R cube by 2, multiplying the entire thing by 2, 128,000 becomes 300 R squared plus R cube. Now what we have to do is, see clearly the last unit digits here are 000. Here also the last two digits will be 0. And therefore here also the last digits have to be 0. So what I'm doing is, I'm just checking with R equal to 20 because I want the last digit to be 0. If we keep R is equal to 20, the right hand side will be 300 into 20 square is 400 plus 20 cube is 8,000, which becomes 120000 plus 8,000, which is 128,000, which is the left hand side. And therefore at R is equal to 20, this equation will hold true. Hence the required rate is 20%. So the answer should be none of these. Trying to solve this for me was a little difficult, and therefore, in a situation like this, I'll tend to use options and then approximate option D. And now, in terms of concept, the concept is not very difficult. All you have to do is put in a formula, but the calculation can be taxing. And once we do reach this point where we have the final equation, getting to the final answer might be difficult. If we are able to spot the 20 and the zeros, then maybe you will be able to solve the question within about 2 minutes, or else the calculation time will increase. The question 2 says, a sum of 9,000 was invested in two different saving schemes. Scheme A offered simple interest. A offered simple interest SI at 16% per annum. Scheme B offered compound interest at 16% per annum with semi-annual compounding. So this is half yearly. The amount received after 2 years from Scheme A was 8 times the amount received from Scheme B. What were the approximate amounts invested in Scheme A and Scheme B? The amount received after 2 years, the amount received, suppose out of this 9,000, we invested 9,000 minus X here and X here. The amount in Scheme 1 will be principal plus interest, principal into rate into time upon 100. This is 8 times of principal into 1 plus rate upon 100. And this is half yearly, therefore 16 by 200 raised to power 4. 16 by 200 will be 4 by 2 by 25. So 27 by 25 raised to power 4. Now, technically, this is one equation in X, and we should be able to solve this equation to get the answer. The only problem is I do not see myself solving this equation without using the calculator, because here we'll have 27 upon 25. We'll have to take the power of 4 of that. The second thing could be if we look at the overall rate in Scheme A, the overall rate will be 16% for 2 years, therefore 32%. In Scheme B, we will have 8% for the first 6 months, then again 8% for the next 6 months, then again 8% for the next 6 months, and then again 8% over the last 6 months. So the interest rate will be 8 plus 8 plus 8 into 8 upon 100, which will be 16.64%. And over the second year, we'll have the same rate, 16.64%. So the overall rate for Scheme B will be 16.64 plus 16.64 plus 16.64 into 16.64 upon 100. So this will give us 33.28 plus 16.64 into 16.64. 16 square is 256 and 17 square is 289. 256, 289. So this should be somewhere around 270, and therefore somewhere around 2.7. So just approximating 35.9 or approximately 36%. So if we look at the amounts, so I'm just removing this equation because this is not something I was able to solve. Now, if we look at the amounts, the amount in the first case will be P into, or 9,000 minus X into 9,000 minus X into 1 plus 32 upon 100. This is 8 times the amount of B Scheme B, which is X into 1 plus 36 upon 100. Now, if the rate was same, say 32 and 32, then we can see that this should have been 1,000 and this should have been 8,000. Only then we'll get the ratio of 8:1 if the rate was same. But here the rate is higher. Therefore, this value has to be less than 1,000. This has to be a value more than 8,000. So the only option that satisfies this is option C, and that should be my answer. I'm approximating outrightly from the options. This for me will be the closest answer, and so I'm marking C. Clearly, this question would be a moderate to difficult question, and the calculation time will be pretty high. Whether we do this in the exam is something that should be taken a call on. The simple interest accrued on an amount of 30 simple interest amount 30,000 at the end of 4 years is 7,200. What would be the compound interest on the same amount at the same rate at the end of 2 years? So simple interest 7,200 is equal to principal into rate into time upon 100. Again, 3 into 24 is 72, out of which 4 is 0, so R has to be 6. 0 cancel, 0 cancel. 4 3s are 12. R is equal to 72 by 12, which is 6. We have to find out the compound interest at the same rate, same amount. at the end of 2 years. So on 3,000, if we look at the compound interest for 2 years at rate 6%, first year will be 6% of 3,000, 6% of 30,000, sorry. 6% of 30,000 will be 1800. 10% would have been 3,000 into 0.6, 1800. In the second year, it will be 1800 plus 6% of 1800 extra, which is 108. And therefore, if we add this, we'll get 3708 in total. And that becomes the answer. Now, this is an easy question, should not take about more than 2 minutes to solve. Direct finding the rate and then compound interest for 2 years, definitely something that should be looked at in the exam. Dhurandhar deposits some money in Lena Bank at the rate of 20% simple interest. He withdraws the money after 1 year, deposits it in Parajaya Bank at the rate of R% per annum compound interest with annual compounding for 2 years, gets rupees 2880 for the total interest from Prajaya Bank. In the first, if the first year interest is 1200, what was the amount he deposited in Lena Bank? Now we know that compound interest for any year increases by R% over the compound interest of the previous year, because the amount is increasing every year by R%, and for every year compound interest is R% of the amount. Even compound interest will increase by R%. Now, compound interest for the first year is given as 1200. Therefore, compound interest for the second year will be 2880 minus 1200, which is 1680. So we can say that 1680 is equal to 1200 into 1 plus R upon 100. So this becomes 1680 upon 1200 is equal to 1 plus R upon 100. 0 cancelled. 8, 21, 15, 3, 7, 5. So this will be 1.4 is equal to 1 plus R upon 100, which means R upon 100 is equal to 0.4 or R is equal to 40%. So the rate that is going on is 40% in Prajaya Bank. Okay. Now, so basically principal P was invested in Lena Bank, which got interest of 20%. So we got 1.2 P. This was then put in Prajaya Bank. In the first year, 40% interest accrued meant 1200 interest in the first year. So we can say 40% of 1.2 P is equal to 1200, or 40 upon 100 into 1.2 P is equal to 1200. 0 cancel. 4, 300. So P becomes 3000 upon 1.2 or 30,000 upon 12. Divided by 3, 10,000 upon 4. 10,000 upon 4 is 2,500. Therefore, the initial principal was 2,500 rupees, which grew at 20% to become 3,000, on which 40% gave first year's compound interest as 1,200. Now, in terms of level of difficulty, I'd say moderate, because there are two levels of computation involved. And the first step, that is getting R, will require some sort of conceptual clarity. Beyond that, it is not very difficult, so should not take more than about 2.5 minutes to solve. If the compound interest accrued on a certain sum at 11% per annum for 2 years is 1064.8 more than simple interest on the same sum, same rate, same period, what is the sum? So basically, we are looking at the difference between SI and CI for 2 years, which is given by PR square upon 100 squared. Difference is 1064.8. We have to find the principal. R is 11, so 11 into 11 upon 100 into 100. So basically, the required P is simply 1064.8 into 100 into 100 upon 11 into 11. So we can divide 1064.8 by 8614 plus 115 minus 11. This will be divisible by 11. 11 9s are 99, 7 4, 11 6 are 66.8. This further should be divisible by 11. 11 8s are 88, 8.8. And therefore, P will be 8.8 into 100 into 100, which will be This becomes 8880, 88, 88 into 123. 88 into 123. So 88,000 becomes the answer, option D. Again, I'd say this is probably an easy sort of a question because direct application of formula and the calculation is also not very difficult. Easy to moderate, about 2 minutes to solve, should be done in the exam. The difference between compound interest and simple interest earned in 2 years on a certain sum at the rate of 18% per annum is 972. We have the rate, we have the difference in SICI for 2 years, we can find the principal. What will the same sum amount to after 3 years at the rate of 18% per annum when the interest is compounded annually? Now, conceptually, the question does not seem very difficult. The calculations might be a problem, but in any case, CI for 2 years minus SI for 2 years is equal to PR square upon 100 squared, formula direct. Difference is 972. P is to be found out. R is 18 into 18 upon 100 into 100. So therefore, P will be 972 into 100 into 100 upon 18 into 18. This is divisible by 9. So 972 divided by 9 will be divided by 18. Sorry, will be 18 nines are 50. 18 fives are 90. 7 to 18 4, 18 fours are, and this is 3 are. So the principal becomes 3000, 30,000. On this, we have to find out the compound amount after 3 years. Now, simple interest for 2 years on this sum will be 30,000 into rate into time upon 100. This will be 6, 3, 3 to the 6, 18 into 6 is 108. 10800. And therefore, compound interest for 2 years will be 972 more than this. So add 972 to it because the difference is given as 972. So 11772. Therefore, amount at the end of 2 years will be 30,000 plus 11772, which is 41772. If the rate is 18%, the amount after 2 years at compound interest should be 41772. We have to find the amount after 3 years. So we increase this by R% because we'll get R% on this. Therefore, 41772 into 1 plus 18 upon 100, or we calculate 18% of 41772. So I'm saying 41772 into 18 is what I want to do. That can be written as 20 minus 2. So 41772 into 20 will be equal to, this becomes 4, 4, 5, 835540 minus 83554, 20 and 20, 20 and 2. So this will come out to 6, 83544, not 54. 83544, 83544. 6, 9, 10, 14, 5, 1, 5, 6, 8, 1, 1, 5, 7. And therefore, 18% or 18 upon 100 of 41772 will be equal to 7518.96. 7518.96. So what will be the amount after 3 years? Amount after 3 years will be amount after 2 years 41772 plus 7518.96. If we add that, we get 9 and 6, 0, 7, 8, 9, 2, 1, 9, 4. 4929 0.96 becomes the answer. As I said, conceptually, this may not be very difficult. The calculation might be a little taxing. I'm trying to not use calculators, and therefore the attempt time goes a little higher. But again, I'd say moderate, 2.5 to 3 minutes should be enough to answer this question. A fund of rupees 50,000 is invested at a rate of 10% per annum, interest compounded annually. annually interest. If every year after compounding the interest at the end of the day, 10% of the amount was withdrawn, what will be the amount left immediately after three such withdrawals? So we start with 15,000. This increases by 10% interest. 10% amount was withdrawn. 10% of 15,000, 1,500. So this becomes 16,500. From this, 10% is withdrawn. 10% of this will simply be 1650. Just remove one zero and subtract. This becomes 15, 100, 7, 8, 1, 4, 1850. This again increases by 10%. 10% of 14850 will be 1485. This becomes 5, 3, 1, 8, 4, 12, 13, 4, 5, 6, 1, 16335. At this point, 10% is again deducted of the amount. 10% of this will be 1633.5. So this becomes 0.5107 6 13 124 1470 1.5. This is the amount after the second year. In the third year, again, this amount will increase by 10%. So we add 10% to this. 1470 1.5, 10% will be 1470.15. So this becomes 1617.65. From this, 10% is to be subtracted. So that will be 1617.165. Because 10% is simply moving the numbers to the right or decimal place to the right once. Decimal to the left, the numbers to the right once. So if we take the difference here, we will get 5, 5, 5, 10, 0, 1, 6, 10, 6, 7, 7, 8, 15, 1, 1, 2, 4, 0.485. Here the difference will be 4. Here it will be 1, 2, 5. 5. Again 5, 1, 1, 2, 4. 1, 4, 5, 5, 4.485 is what will remain. Enter your answer in the decimal value rounded off to two decimal places. So the answer that we will input will be just clearing this out a little bit. The answer that we'll input will be 14,554.49 up to two places of decimal. That becomes the answer. Again, conceptually easy question. The calculation might take a bit of time. So therefore, I'm saying about 2.5 minutes to solve. But again, since I know I'll get the answer easily, I would attempt such a question in the exam. A company took a loan for 3 years at 20% CI with annual compounding. It repaid the entire loan amount in three equal installments of 2160 crores each. What was the amount of the loan taken? Suppose A amount was taken initially, and then 21.6 CR was paid after each year for 3 years, right? Now, the value of this will, what we can do is we can take the value of each of these sums of money at the start of the time and equate to A. So the amount will simply be, the first sum of money will be divided by 1 plus 20 upon 100. When we go forward, we multiply by this. If you have to go backward, we'll divide. The second will be 2160 upon 1 plus 20 upon 100 whole squared. Finally, 21.60 upon 1 plus 20 upon 100 whole cube. So this becomes 21.60 upon 1.2 plus 21.60 upon 1.2 into 1.2 plus 21.60 upon 1.2 into 1.2 into 1.2. I am just taking or accommodating for the decimals first, and then I'll try to divide. This can be written as 216 upon 12 plus 2160 upon 12 into 12 plus 21600 upon 12 into 12 into 12. Now 216 is 6 cube. So if we divide by that, we get 36 here and 2 here, so 18. Again 6 cube, so we'll get 360, 2, 180, 12. 12 into 15 will be 180 plus this will be 3600 upon 2. So this will be 1800 divided by 12 will be 150. 150 divided by 12. Divided by say 6. This is 2, this is 25, and therefore 12.5. If we add 30.5 plus 15, 45.5 CR becomes the starting amount. Again, because of the numbers, I'd say easy to moderate. The solving time might go up to 3 minutes, but installment based basic question could be attempted in the exam. A certain sum of a certain sum is invested at simple interest. If the sum becomes k times in 16 years and 2k times in 40 years, in how many years will it become 4k times? Now, if the principal becomes k times, this is the principal, this is the amount. The simple interest will be amount minus principal. So this will be k minus 1 into p. Similarly, if the principal becomes 2k times 2k into p, the simple interest here will be 2k into p minus p, which will be 2k minus 1 into p. Now we can say that simple interest in 16 years is k minus 1 into p. Therefore, simple interest in 1 year should be equal to k minus 1 into p by 16, because simple interest is same every year. So simple interest in 40 years should be 40 into simple interest for 1 year, which is k minus 1 into p upon 16. But we also know that in 40 years, the principal becomes 2k times. So the simple interest for 40 years will also be 2k minus 1 into p. Therefore, we can say 2k minus 1 into p will be equal to 40 into k minus 1 into p by 16. So we proportionally found out simple interest for 40 years, since we knew the simple interest for 16 years, and equated that to simple interest for 40 years given in the question. P and p cancelled. 8 5s are 40, 8 2s are 16, cross multiply. 4k minus 2 is equal to 5k minus 5. So k is equal to 3. K is equal to 3. That means p becomes 3p in 16 years, which means we get 2p interest in 16 years, or p interest in 8 years divided by 2. Similarly, p becomes 6p in 40 years, which means we get 5p, 6p minus p interest in 40 years divided by 5p interest in 8 years. As we can see, the numbers tally. In how many years will it become 4k times? P to become 4k, k is 3. So P has to become 12p. So simple interest has to be 12p minus p, which is 11p. P interest is there in 8 years. 8. So for interest P, time taken is 8 years. So for 11p, time taken will be multiplied by 11, 88. Hence, the principal will become 4k times in 88 years. Again, in terms of concept, the concept is not very difficult, but unless it is completely clear, solving this might be a problem. I'd say a moderate to difficult level of question, but a good question that should be looked at. Whether you do it in the exam or not is a secondary discussion. Maybe not, maybe if you're comfortable, but certainly something that you should try to do otherwise for practice. If the population of a town is P in the beginning of any year, then it becomes 3 plus 2P in the beginning of the next year. If the population in the beginning of 2019 is 1000, then the population in the beginning of 2034 will be. There are 4 options given. So what I will try to do is I will use this P and try to form a expression which is similar to the options, and then solve. Now, if in 2019 the population was P, in 2020, 1 year later, it becomes 3 plus 2P. In 2021, it becomes 3 plus whatever it was existing. So 3 plus 2 into 3 plus 2P. P comes here, so this entire thing will come here. So this is nothing but 3 plus 2 3s are 6 plus 2P, which is 9 plus 4P, sorry. 9 plus 4P. 1, 2. Okay. Then in 2022, this will become 3 plus 2 into 9 plus 4P, which means 3 plus 9 is 27, plus 8p, which means 30. 9 twos are 18, not 27. 18. So 21 plus 8p. Now clearly, if we look at the p term, here it is 2 raised to power 1 into p. Here it is 2 raised to power 2 into p. Here it is 2 raised to power 3 into p. 1 year later, 2 raised to power 1 into p. 2 years later, 2 raised to power 2 into p. 3 years later, 2 raised to power 3 into p. So the power of 2 will be 15 in the answer, hopefully. Now we have to reach the first term. We have a plus 6 or a minus 3. Now, if what we do here is we look at or we try to make this a power of 2, 6, 6, 6, 6. So what we can do is we add plus 3 and minus 3 here. Therefore, the first term will become 6 plus 2p minus 3. Now, taking out 2 common, we'll have 2 into 3 plus p minus 3. Similarly, for the second term, if we subtract 3, we'll have 12 plus 4p minus 3. So this becomes 4 into p plus 3 minus 3, which is nothing but 2 square into p plus 3 minus 3. If we look at the third term and do the same thing, we'll have 24 plus 8p minus 3, adding and subtracting 3. Why are we subtracting 3? Because we had two options, either add 6 or subtract 3. I'm checking with the first, with subtracting 3, that works out. If that did not work out, I would have added 6 and checked. So this becomes 8 into 3 plus p minus 3, which is nothing but 2 cube into 3 plus p minus 3. Now, if you look at each of the terms, p plus 3 minus 3 is common. The power of 2 changes. So after n years, or n years after 2019, n years after 2019, the population becomes 2 raised to power n into 3 plus p minus 3. 2019 starting population p is given to be 1000. So the population after n years will be 2 raised to power n into 3 plus 1000. 1003 minus 3. We have to look at the population after in 2034. So 19 minus 34 is 15 years. So the required answer will be 2 raised to power 15 into 1003 minus 3, which happens to be option C. Again, I would call this question moderate to difficult. Unless you're able to rearrange the numbers, it might be a little difficult to solve. But once it does strike you, you'll realize, especially 2 raised to power 15 part, once it strikes you, you'll realize that the only option that kinds of fit is option C. So working from there is not difficult. But again, I think moderate to difficult, 2.5 to 3 minutes to solve. Now, if you look at the overall analysis of this test, as I said initially, the overall level of difficulty is moderate because there are 2 or 3 easy questions or easy to moderate questions which we will be able to spot. And therefore, going towards the attempt of 6 questions will not be very difficult. But there were a lot of questions where there was calculation involved. Therefore, overall attempt time would be 24 to 27 minutes. Which will be the 6 questions that I would attempt? For me, there will be 1, 3, 4, 5, 7, and 9. Just to have a look at them. I would have done this for the simple reason that while solving r is equal to 20 gave me a direct value, and therefore I was able to solve, not solve, but get the answer as none of these. Here, I was not able to get the exact answer. Also, the answer asks approximate amounts. So calculation will be difficult. So I might have left this in a timed exam. This was, I think, a straightforward question. Just find R and then the CI. So I would have attempted this. This I thought was easy. Just have to put in the formula for compound interest to get the rate, and then the rest of the calculation was easy. So I might have attempted this. This I think was easy. Just put the formula and solve. Here the calculation was a little bit difficult, and therefore, depending on time, this may or may not have been attempted. This I thought was easy. And just calculation was there, and for the first 2 years, the calculation was not even very difficult. Only for the third year, there was some difficulty, so might have attempted this question. This question again, I might have done it. But since there is installment and we have a factor in the denominator, might be difficult for some of us. This is something that I would have attempted because I'm comfortable with the concept. So if you're choosing, you could choose one of 8 or 9, and then 10 again is something that might strike, might not strike. So the question that we talk about are 1, 3, 4, 5, 7, and either one of 8 or 9 could be the 6 questions that we attempt.